6, talk about linear inequalities, okay? So before we talk about linear inequalities, I want to kind of take a step back and we're just going to kind of work up to this because the idea of what we do today is really pretty simple, but I really want you guys to understand what we are doing today. So we always usually start, okay, with an equation. So like at the beginning of the year, we started with an equation, and when you solved an equation, we got, okay, x equals 2. So whenever I ask you what does x equal, x is 2, and that's it. X is only 2, and that 2 is the only thing that x can be. And after we finished with equations, we moved on to inequalities. And with an inequality, you didn't get an answer like x equals 2. You maybe got an answer like x is greater than or equal to 2, which means, yeah, x could be 2, but x could also be 3 or 4 or 5, right? So where this has just one answer, okay, this, whenever we graph these, I know that's been a long time, had a ton of answers, 2 and all the numbers bigger than 2, okay? Well, then we did a whole bunch of other things. And then in chapter 5, we started linear equations. So this was just a regular equation. X is 2, that's it. But then we did linear equations. And a linear equation might have said, like, y equals x plus 2. And here's the thing. This doesn't just have one answer, okay? It has an infinite number of answers. Because remember how these work is we could say, okay, well, maybe x is 2. But if x is 2, y is going to be 2 plus 2, so y is going to be 4. So one answer for this equation is 2, 4, but that's not the only answer. Another answer, well, maybe x is 3. Well, if x is 3, 3 plus 2 would tell me that y is 5, so 3, 5 is also an answer. So is 4, 6, and I could keep going, 5, 7, 7, 8. And I can't sit here and write out all of the answers. So what we did with this, kind of like with the inequalities, how we graphed them, because I can't write out all the answers greater than or equal to 2, but I could graph them. What we did here is we graphed this as a line. And when we graphed this, we said, okay, every single ordered pair on that line is a solution. I can't write them all out, but I can graph them. I can show that every single point on that line is a solution, okay? What we're doing today is really similar to this, y equals x plus 2, but instead of an equal to, it's going to have an inequality symbol. Now really, it doesn't change a whole lot. It's going to be really, really super simple, okay? Here's how we are going to graph linear inequalities. 4 steps here, okay? First step to graph inequalities, okay? It's the same first step as to graph linear equations. Linear equations are super, super incredibly easy to graph if they're in the right form. Remember the y equals mx plus b, okay? That's the first thing we're going to do is we are going to solve for y. Meaning, it should say y equals mx plus b, except it's not going to be an equals. It's going to be a greater than, less than, greater than. It's going to be an inequality symbol. Okay? First thing, solve for y. Okay? Next thing you're going to do is you are going to graph using slope and y-intercept. Graph using the slope and y-intercept. Exactly like we did with the equation, right? Plot the y-intercept, and then your slope tells you rise over run, plot the second point. Okay, now, from here, here's where things change a little bit. Okay? If you remember, back in chapter 3, whenever we were doing our review, and we were graphing inequalities like this, okay? So if I had x is greater than 2, when we graph these on a number line, we put a closed dot at 2, because I said, okay, well, x can be 2. So we shaded in the 2 with a closed dot. If I look at a super similar inequality, like x is greater than 2, on a number line, it looked almost the same, but what we did is we used an open dot, okay? We used an open dot to say 2 is not a solution, but everything greater than 2 is a solution. So when I saw the closed dot, that's a solution. solution. In my brain, I know that's a solution. If I saw an open dot, that's not part of the solution set. We need a similar thing here whenever we're graphing the lines, okay? Except I can't really use dots because it's a line, okay? So how we're going to show the difference between a closed dot or an open dot, between an equal to or a not equal to, is you are either going to use a solid or a dotted line. So the next thing you're going to do is you're going to decide, once you have your line graphed, you're going to decide, should it be a solid or a dotted line? We'll talk about how you're going to know that. And then the last thing you're going to do, the points on that line may or may not be part of the solution set. We'll talk about that again in a second. But for certain, those points on the line are definitely not the only points on the line. If you remember when we graphed x is greater than 2 or x is greater than or equal to or one way or the other, we had to shade either to the right or to the left. Because either the numbers greater than 2 are a solution or the numbers less than 2 are a solution. The same thing's going to happen here, but with all of the ordered pairs. And what's going to happen here is either the points above the line are going to be also solutions, or the points below the lines are going to be parts of the solutions. So the last thing you're going to do is you're going to shade either above the line or below the line. For the most part, this is just like graphing linear equations using slope and y-intercept. There's two differences. Okay? So let's talk first about how we're going to know if we're going to use a solid or a dotted line. Now remember, if it wasn't equal to, over here, if it wasn't equal to, we used a closed dot. We shaded in the dot to show whatever I shade is the solution. So when I use a solid line, like when we graph normally, right? Whenever we graph normally, we just use a solid line, right? It means that those points on that line are a solution. So we are going to use a solid line if it's a less than or equal to, or a greater than or equal to. Because since it has that equal to, the points on the line are part of the solution set. They would work in the inequality. Okay? Now, how we're going to show if it's a less than or a greater than, just like if it said x is greater than 2, 2 is not part of the solution set, so we'd use an open dot to show 2 doesn't work. Everything to the right of 2 does. What happens here, all the points on the line, they are not part of the solution set. So I can't use a solid line because a solid line means they're a solution. So we're going to use a dotted line for those ones. Okay? Now, to decide where the other solutions are, because the points on the line may be a solution, but they may not be a solution. Now, especially if they're not a solution, there has to be a solution to the inequality. It's either going to be the points above the line or the points below the line. And this is really easy to decide. You are going to shade above the line if it's a greater than or equal to. And guess what? You're going to shade below the line if it's a less than or less than or equal to. Okay, so this kind of seems like a lot. I promise you, it's not. Okay, let's go through this first example, and I will also warn you that this first example is probably the hardest one you'll see today. I don't even know if your homework examples have one this difficult, but it's a good one to start with. Okay? I want to graph this inequality. Now remember, we graph this because there's an infinite number of solutions here. Okay? I could not possibly write out every single solution. So what I'm going to do is I'm going to graph them all. So I need to first graph this line. Okay, I'm going to graph this line. But if I'm going to graph this line, it has to be in y equals. So we're going to have to solve that inequality for y, just like we did whenever it was an equation. So usually we have to move the x term first, so that's what we're going to do here. It's a positive 2x, so we're going to subtract 2x from both sides. When I subtract 2x from both sides, there's still a negative 3y on the left-hand side is less than. Remember, I cannot combine the 12 and the negative 2x because one's an x and one's not. So it's just going to say negative 2x plus 12. And then to get rid of the negative 3, we're going to divide by negative 3. Now here's where you have to be really careful. Do you guys remember me yelling at you a lot whenever we did inequalities? And I was like, we divided by a negative 3! Why did I yell? We divide an inequality by a negative. You gotta flip the sign, remember that? Okay? So what's gonna happen here is this less than is actually gonna turn to a greater than. Okay? So it's gonna be y is greater than, and then we have to do the butterfly method over here. Negative 2 over a negative 3 is gonna be a positive 2/3 x. 12 over negative 3 is gonna be negative 4. Okay, that's the hardest part of this. I promise you that. Okay, once you have it in y equals, this part is exactly like as if this were an equation. To graph this line, you're going to start with the y-intercept, which is at negative 4. So we're going to go down here at negative 4 and put a point. The slope of this line is 2/3. So we're going to rise 2, run 3. Now here's probably the hardest part about this, is our automatic reaction here is say, okay, connect them, there's my line. Here's the thing, whenever you connect your points, you're not always going to use a solid line. Because a solid line means, and don't do this, okay? A solid line means that every single ordered pair on that line works. And that may not be true. Because this is just a greater than. It's not an equal to. Since it's not an equal to, it means that these points on this line, they don't work. It's like the x is greater than 2. 2's not a solution. All of these points on these lines don't work. They're not a solution. So how I show that is I use a dotted line. And that way I can see that visually, it's just kind of like a boundary. Okay, it's just a boundary. Now, if I just look at this, there's no solutions here. That's a dotted line, okay? But there are solutions here. Either, and it's always going to work out this way, okay? The solutions here are either going to be the points up here or down here. And how you're going to decide is you're going to look here. Now, you have to go to the equation you solve for y, and since it's a greater than, you're going to shape above the line here. And I like to use a highlighter just because it covers a little bit better. You definitely do not have to. But by shading above this line, every single point above that line would work in this inequality. To show you that it's true, somebody pick a point in that shaded area. What's any point in that shaded area? What is a solution? What's an x comma y in the shaded area? -3 and 4. Yeah, see how it's in the shaded area? See that? To show you that -3, 4 works, I can plug -3 in for x, so 2/3 times -3 minus 4, and I can plug in 4 for y. It should work. Watch this. Okay, the 3's cancel out, so that gives me -2 minus 4. 4 is greater than -2 minus 4 is -6. Is 4 greater than -6? See how it works? Every single point. You could pick every single one. You can pick 0, 0. That's an easy one to pick. 0 is greater than 2/3 times 0 will just give you 0. -4 is 0 greater than -4. Every single point here would work. Now, if you decided to pick a point over here, it wouldn't work. It would give you a false statement. It would say like 0 is less than -4, which is not true. Okay? All right, so let's go ahead and let's get this glued into, let's see what page we're on. We should be on page 61. Page 61, section 6.5, and this is linear inequalities. Okay, so in your homework, for the most part, you're going to be graphing, but a few of these is just going to be kind of application. Are you really understanding what we're doing? So the first thing we're going to do is we're going to decide whether the ordered pair is a solution or not. So I'm going to give you an inequality. So let's say we have y is greater than x minus 1. There's my inequality. And we have the point 0, 1. So what I'm wanting to know here is that if I were to graph this inequality, I don't have to graph it, okay? But if I were to graph this inequality, I want to know if 0, 1, if it would be in the shaded area. If it's in the shaded area, it means it'd be a solution. Or if it wouldn't be in the shaded area, which means it's not a solution. Now, one way you could decide if it'd be in the shaded area is you could actually graph this inequality. We don't have to graph the inequality. An easy way to know if I could decide if this is going to be a solution or not, if it's a solution, it should work. Meaning, if I plug in 0 for x and 1 for y, it should work. So that's all you have to do. So instead of y, we're going to plug in 1 is greater than. Instead of x, we'll plug in 0. So I just need to know, is 1 greater than 0 minus 1? 0 minus 1 is negative 1, so is 1 greater than negative 1? Yeah. So yes, if you were to graph this, you don't have to graph it, but if you were to graph this, 0, 1 would be in the shaded area. Let's do another one of those. Let's say 3y is less than 5x minus 12. 3y is less than 5x minus 12. And the point is going to be negative 6, 1. So same idea here. Same idea here. If I want to know if this is going to be in the shaded area or not, you're going to plug in negative 6 for x, plug in 1 for y. So it's going to be 3 times instead of y. We're going to plug in 1. If it's a solution, it needs to be less than 5 times. Instead of x, we'll plug in negative 6 minus 12. 3 times 1 is 3, is less than. 5 times negative 6 is negative 30 minus 12. So I'd have 3 is less than negative 42. Is 3, positive 3, less than negative 42. So if you were to graph this inequality, that point, negative 6, 1, would not be in the shaded area. So you'll have a handful of those for your homework, and the rest of them you are going to be graphing. So let's practice a few of these. Okay, so number 3, y is greater than or equal to 3x minus 2. So you're going to be doing the same thing in your homework. I didn't have graph paper for you. Just make them as neat as possible. We've done these before. I guess if you really need graph paper, you can use graph paper, but you definitely don't have to. Okay? The number one thing, the absolute number one thing, it has to be in y equals, or y is greater than or equals to. The y has to be by itself, which in this case, it is. Okay? So if it's in y equals, you're going to go ahead and start graphing it like you normally would. So we need the slope and y-intercept. So what's the slope of this line? Just the slope. What's the slope? Remember, it's y equals m3. And remember, we like our slope as a fraction. So 3 over 1. What's the y-intercept? Negative 2. So the first thing we plot is negative 2. So down here at negative 2, we're going to put a point. Okay, the slope is 3, or 3 over 1. So from this point, you are going to rise 3, run 1, and put a second point. Now, I think the hardest part of today is we automatically want to go ahead and connect these and form our line, which you just need to hold on for a second because you're either going to use a solid line or a dotted line. So how you're going to know is you're going to look at your inequality. If it's a greater than or less than, you have to use a dotted line. If it's an equal to, you can use a solid line. Which one will I use? Yeah, it's an equal to, which means all of these points are 0, -2, plug it in, it worked. You could pick your 1, 1, plug it in, it worked. All of these points on this line work. Now here's the thing, those are not the only points that work. There's another half, I guess, of your solutions. And it's either going to be the points above the line or the points below the line. You're going to look at your inequality. Since it's a greater than or equal to, it's going to be these points here above the line. You're going to shade above the line. Okay, let's try another one. Let's do y is less than 2x minus 6. Okay, first thing, number one thing, it absolutely has to be in y equals. None for me, right? So what's the slope of this line? 2/1. Great, I love the 2/1. That's awesome. What's the y-intercept? -6. Very good. So we're going to start all the way down here, -6. 1, 2, 3, 4, 5, 6, and we're going to put a point. From there, my slope is 2/1. So make sure you rise 2 and make sure you run that 1. Now, before you connect your line, I know it's really tempting to just go ahead and just connect it on from there. But in this one, see how it's just a less than? It's not an equal to. The points on this line, they're not part of my solution set. So if I use a solid line here, that's not accurately showing my solution set. So I have to use a dotted line here. And the dotted line is going to tell me that it's kind of just a boundary line. These points don't work. They just kind of separate the solutions from not the solutions. So far, I have no solutions because the points on the line don't work. But the solutions are either going to be the points above or below the line. This time, I have a less than. Since it's a less than, this time, you're going to shade below the line. These are the points that would work for that inequality. Okay, number 5. Number 5 says y is less than or equal to x. Okay, now these ones always get students. Is it y equals? Yes. It is in y equals. What is my slope? 1. If you have an x, which I do, your slope is the number in front of x. You have a slope here. It's 1/1. Now, the y-intercept is that number at the end, and this time I don't have a number at the end. What number could it be? 0. And it had to be 0, right? Because you could do +0. That wouldn't change anything, right? When you add 0, it doesn't change your answer. So to graph this, you're going to start at 0 and put a point. And then my slope is 1, which means I'm going to rise 1, run 1. And then before you connect it, look at your inequality. Solid line or dotted line? Solid, because it's an equal to. So we're going to use a solid line. And then lastly, it's a less than, so we'll shade above or below. So it's really not a whole lot different from graphing equations. 2 differences, solid or dotted line, and then shade above or below. Okay, just a few more. Okay, number 6 says y is greater than or equal to -1. Now this one's kind of similar to the last one. What's different about this one? It doesn't have an x. It is a y-only line. Why can't I remember what a y-only line looks like? Why is that so hard to remember? Why? What does a y-only line look like? Right? A y-only line is a horizontal line, okay? And when we're doing this, On your y-axis, at -1, draw your y-only line. But before you draw your y-only line, is it going to be a solid or a dotted y-only line? Solid y-only line. And if it is a greater than or equal to -1, am I going to shade above or below the line? Above the line. Now, if you have an x-only line, that's an x like an x, you can't really shade above or below a vertical line, but if it's a greater than, you'll shade to the right of it. If it's less than, then you'll shade to the left of it. Okay? All right, let's do two more that are maybe a little more challenging just to put into y equals, and then you guys can get started on your homework. Okay, number 7. Number 7 says 2x minus 3y is greater than or equal to 9. All right, what's my first problem here? What? It's not in y equals, which is not a big deal because we're really good at that now. You got to move your x term first. It's a positive 2x, so we're going to subtract 2x from both sides. When I do that, I still have a negative 3y is greater than or equal to negative 2x plus 9. And then to get rid of the negative 3, we're going to divide everything by negative 3. But when I divide an inequality by a negative number, we have to switch the sign. So it's going to be a less than or equal to. And then negative 2 over a negative 3 is going to be a positive 2/3 x. And then 9 over negative 3 will give me negative 3. Okay, where do I start to graph this one? Where's the first point and graph here? Negative 3. 1, 2, 3. So we're going to put a point at negative 3. From there, what do? Rise 2, run 3. And before you connect it, solid or dotted line? This is going to be a solid line. And the last thing, you have to look at the y equals inequality, because it's different than this one, right? Because we had to flip it around. Are we going to shade above or below the line? Below, because it's a less than. So we're going to shade below. All right, last one here, number 8. Number 8 says x minus 3y is less than 15. Okay, what's my first problem here? Not in y equals, just like the other ones, move your x term first. So we're going to subtract x from both sides. Just like the last couple we've done, I still have a negative in front of the 3. So it's negative 3y is less than negative x plus 15. And just like the last ones, when I divide by a negative 3, we have to flip the sign. So it's going to be y is greater than. Now, be careful here. We've talked about these ones a lot, but they're still really challenging. When I have negative x over negative 3, first of all, negative over negative, positive. Remember, when this happens, when you have x over 3, what you're going to do, write the 1 in front of the x that we don't normally write, but write it, and kick the x out of the fraction. And we're going to call it a 1/3 x. And then we have 15 over negative 3, which is negative 5. So we're going to start by putting a point at negative 5. slope is 1/3, so rise 1, run 3, solid or dotted line. Dotted line. And make sure you go to your y equals line. Am I going to shade above or below? Above. So all of these points. And keep in mind that I don't technically graph all of them because I would have to have all of the paper in the entire world and there would still be more solutions. This shaded area keeps going, even past what I actually shaded and what I actually drew. Okay, so keep that in mind as well. Do you guys have questions?